Ready to get started?
Yeah.
All right, let's do it. I'm Jamie Heller. I'm the Editor-in-Chief of Business Insider. Thank you so much for being at the AI House today. We're talking about future deep tech, what's next for AI. We have a terrific panel, and I'm going to do my best to get these names right. We have Adrian Locher, founder of Merantix Capital, also co-founder of AI House, and an investor. So thank you for being here. We have Andrey Khusid. I'm flipping around a little, sorry. Andrey, and founder and CEO of Miro. We have here Deepak Pathak.
Yes.
And co-founder and CEO of Skild AI and professor at Carnegie Mellon University. And now Kalchbrenner, who is a research scientist in AI, a founding member of Project Prometheus, and many years at Google DeepMind.
That's right.
So thank you all for being here. Thank all of you for being here. So I'm going to start out with something I've been hearing around the promenade that might be familiar to many of the more sophisticated science folks in the room, but certainly interesting to me. Are we like peak LLM? Are LLMs just the thing of yesteryear, and were they a little oversold? Can we take that before we get into what's next? Like, where are you seeing LLMs right now? Do you want to start?
Yeah, I think, you know, when I learn something about technology, then it is when I think we're peak, we're probably only at the start, right? So because when you're in your bubble, then you always feel like things are already quite well ahead. But then when you look into reality and where, you know, classic industry stands, then usually they're just at the beginning. And I think LLMs are a terrific technology, and they have been bringing AI to the attention of the broader public. And yet they're a very small part of what AI is, and especially also will be in the future. So,
did we appreciate what a small part they were, or is that becoming more clear now?
I think they are a general purpose technology in itself, and so they are laying the ground for much more what is going to be built on top. And that's also what I think needs a bit more attention here is not the technology itself, but it's what you actually build on top and what you need it for.
So why don't we just get right into that, which is what's coming next. Nal, do you want to start?
Yeah, sure. I mean, I actually don't think we're in peak LLMs. I think LLMs keep on really showcasing unique capabilities. We've seen LLMs solving theorem proving, pretty remarkable theorems. We see LLMs doing, really advanced cognitive work. And I don't see the progress they're slowing down, and I can speak for I think many scientist colleagues who don't see any progress slowing down. At the same time, one thing to understand is maybe there's two limitations in LLMs. One is that LLMs are still an abstract model of reasoning, and when the average user confronts an LLM, they come with this whole context and this whole understanding of their own problem, and then they try to sort of write it out in text in this context in the LLM, and then they look at the outcomes like, oh wait, this is not what I was expecting, or something like this. And this level of abstraction, also referring to what was said, is part of the problem. This overcoming the abstraction is quite difficult, and this is why all kinds of products are built on top of LLMs to try to close this gap. But the reasoning prowess of LLMs itself is actually pretty remarkable. Another limitation, which actually goes back to sort of like what comes next, is that there is, however, a lot of human intelligence, a lot of human cognition, which is not written out on the internet. There's a lot of know-how in every industry that is beyond, that is not even linguistic, and it's not even. It's about perceptual knowledge, perceptual understanding, how a designer looks at at some material on a chair, or how a car expert is testing a car for its abilities. And this type of knowledge is not being captured. In fact, this type of knowledge is not even being measured. It's very hard to measure this type of knowledge, and this is also a gap in the LLM performance, I think, in this type of cognition.
You were telling me in the green room how a watchmaker would know
Yeah, of course. Well, this is another example. I mean, I'm not no watchmaker, but because we're in Switzerland, maybe a watchmaker is choosing the material for one piece of the 300 pieces in the watch. And what is interesting is not in the properties of the material itself, but in the sound that it makes when the watch clicks. And this is such a specialized know-how that they might have. There's plenty of examples like this of very specific knowledge which is not covered by the internet or by LLMs.
And do you see potential for that to be captured?
Well, that's kind of going towards the next phase. I think there will be. I think it's pretty hard to capture that. You have to measure it in some ways, and I'm happy we should talk about it. But it's not. They might. Yeah, it's complicated. And actually, in this last part is also where I think that all this talk about LLMs, replacing humans and so on. Actually, this last part, this expertise will really stay. This generational expertise that humans have built over decades or centuries that is not being captured across the industries. This will really stay a unique human expertise for a while, I think, actually. Yeah.
Deepak, you want to get in on this? Because
Yeah.
you're having a different approach. Tell us about your company and what you're working on.
Yeah, so I'm CEO and co-founder of Skild. At Skild, we are building a general purpose brain for robotics, okay? Like what you think of like OpenAI, ChatGPT for language, we are building general brain for robotics. I want to get back to your question about is peak LLM yesterday, right? And why do we feel that way? Because if you talk to any scientist, any researcher, they will say they are not yesterday. Every month we see new breakthroughs. Even a few months ago, like the math Olympiad gold medal, like it's amazing feat. But still, if you ask any person on the street, they will say, yes, it seems like past yesterday. Why does it feel like that? There is a quote, I'm forgetting who said it. Humans are always way over, they overestimate the progress in short term, but they underestimate the progress in long term. And that's what it feels like. People underestimated AI for years, and then ChatGPT came, and suddenly it seemed like, oh, wait, in next year my life will change. And things are changing at an exponential pace, but it's the mismatch between your expectation and reality which makes it feel like yesterday. But even though the graph shows you're consistently making progress. And that's when you believe, okay, my life will change tomorrow. Like next year, I don't need to have a house or anything. Like AGI
Or
is coming.
retirement,
or
yeah.
AGI is coming. And then you see something else. And, oh, Math Olympiad. Okay, how does it help me? But you feel like, oh, it's yesterday. But that is the mismatch which is causing this. But I believe in the next set of applications of AI we are seeing, what LLM showed us is not that you have fancy chatbot. What they showed us is that if you have enough data, you can train models which can represent that data very well and go beyond that. And that is the biggest finding from the LLMs. Like we can automate things which previously we did not even think were automatable. This is where robotics comes into play next. Now, robotics has, generally in AI, they have a big challenge. Like AI came for language, okay, really good results. Came for images, really good results. Videos, really good results. Speech, really good results. Now everybody is like, next is robotics. Like AI coming to kill all the fields in a way, right? And the thing is, but people forget, the recipe for AI is data and big models. Where is data for robotics? Like there is no internet of robots. And physical world, physical reasoning, what governs almost every business. Even like internet is about, I don't know, like 30, 40 years old, like maybe let's say 50, right? But economy existed even before 50 years ago, and it's all physical. And that is the biggest next frontier of AI, which we are, I would say, just beginning, like not even the beginning, like we're not scratched surface at all. So we are not at all past the peak AI. We are yet to approach it.
But how much are they related? Like how much are the LLMs the foundation for the physical?
Correct.
Like how connected is
So
it?
LLMs are not really the foundation for the physical, they are foundation for digital. But what they have shown us is it is even possible to build the foundation. Like even, you would say 5 years ago, even in language land, everything you see in today's application of LLMs, they were all separate. I think Nal worked in language and other areas. So translation, different system. Question answering, different system. Math, different system. Theorem proving, different system. And they were all different areas of AI. But now, everything is LLM to some extent, and then you can fine tune, etc. So what LLM showed us that given enough innovation, you can build foundation, and that's how they are helping other areas of robotics. They are foundation models of digital intelligence, but not physical.
So I'm just going to phrase it one more way. Like, how much do you feel you're starting from scratch in what you're doing, like at the beginning versus like building on what's out there?
So in robotics, you do start from scratch.
If I can ask, just tell everybody what your company does. Just
Okay, so we built, again, brain for robots, right? And any robot, any task, one brain. So when I say, it may sound, okay, yeah, it's a general model company. But you think deeply. I say any robot. So robot can be humanoid, can be a dog-like robot, can be arm, and we build unified brain for all. Now, why do we go so general? Well, if you think of robotics in your head, if you think of GPT in your head, you think of brain, intelligent, consciousness. And I say, think of robotics, you think of hardware. And largely from like R2D2, or depending on which generation you are, like different pictures, you always think of hardware. We have seen amazing robotics demos from so many companies for the last 70 years. And those who've been around for 70 years, they know there were robots doing stuff even 70 years ago, but still no robots around us. And the reason is what has been missing is brain for robots. And that is the gap we fill. I can go more into it, but that's the main idea. And the difference from LLM land is there is no data for robotics. So we have to really innovate on the side of how do we leverage alternate source of data. So we leverage human videos and simulation to bootstrap the problem. So which is where we differ from LLMs. But how you learn these things, that learning component is shared.
Shared, I got it. Okay, but it's different data inputs.
Different data, and which is not direct data. So you have to do a lot of innovation.
So Andrey, tell us, Miro started before LLMs, really, and where are you on your path? Tell us what it is and what you're up to.
It's been a fun journey for us. Miro is existing for 15 years. So it started with a very simple idea of bringing whiteboard into a browser. And the idea was because people want to communicate, collaborate, but they might be distributed, and the whiteboard in the browser can help them to come together and collaborate. Now, obviously, it evolved into a visual collaboration category over time. It became a kind of major thing where people come and solve problems together. But then in 2022, ChatGPT moment happened, and a lot of people start to move from individual brainstorms or collaborative brainstorms into brainstorms with LLMs, correct? So it's like, before I would go and map my ideas on a canvas, and I would try to make sense out of that myself. But then you can start doing it with an LLM, kind of say or write whatever you want, and then LLM kind of help you to think through together. That's what happened, and we start to think how to reinvent ourselves for this new world. And it was mentioned here that there are a lot of knowledge that is not still captured and that is not yet kind of common knowledge for LLMs. We call it team intelligence, because in companies, you're not progressing the work individually.
Team intelligence.
Yeah, so you progress as a team. So even if you drive individual productivity up, the project may take exactly the same time because there are many people who have to work through the project. So it's like 9 months, 12 months, this doesn't change. And we are thinking and progressing on the vision how we bring AI into the teamwork, and where AI becomes not a kind of individual partner to think through, single player, correct? Like what's happening today when you go into any LLM, but how it becomes the team player. So if you are a team sitting at a workshop and trying to figure out the strategy for the next year, you have 5 people in the group that have different knowledge and skills, but how LLM can be a part of that group and be progressing you through thinking, but then not just progress through thinking, but also take that vision and execute together as a team. So that's where we see a big opportunity, because again, as I say, like LLMs originally are single player platforms, and companies are not working in silos. Like, I mean, it's not individuals who are working in silos. It's a group of people who have to progress together. And there are big problems that can be solved. One of the biggest problems is silos in the company, correct? We all work in the companies where even tens of people, they don't know what's going on. There's like some things that are happening in parallel that have to be aligned, some duplicative work and whatnot. And I think LLMs can solve that problem.
So that's sort of next generation Google Docs, Slack, like.
Which breaks the silos, bring things together. Yeah, I hope Miro also will be in the line of products. And we actually, we innovated that interface. We just started, but it's fascinating how much you can do if you bring AI into a teamwork rather than into individual collaboration.
Got it. Okay, so Deepak, you've talked about omni-bodied intelligence. That's what you're working on, and we're talking about team intelligence, and we've talked about expertise. But now, can you also talk about how you see a potential here in advanced sciences?
Yeah. Yeah, for sure. So yeah, actually another maybe gap of knowledge in LLMs that is not just this unspoken human expertise is actually advanced laws of the physical world, right? There is when we have science, we have a long tradition in science in the world, and it's very and a lot of really advanced innovation, technology, applications, and discovery on the human side actually relies on this complicated experimentation, interaction with the real world to either measure what happens at those advanced physics and chemistry, or to simulate what happens there. And LLMs don't have this information. This data is actually pretty scarce, and it's very, very hard to come by. But it's at the core of the biggest breakthroughs, whether it's in medicine or in technology. And I don't see LLMs, besides reading textbooks for already known knowledge, LLMs don't have this information. So I think there's going to be but there's a big desire of actually capturing this somehow in the AI, and that means potentially new measurements, new scale of measurements, or collecting scientific data at a completely new scale from the real world, and try to make sense of it. And this could be a next wave. Could be a real next wave, and then potentially combine it with general reasoning, advanced reasoning, like in LLMs. But all this information is just not there. So this is I think this is going to be quite a big area going forward. Yeah.
It's funny, as a journalist, I think that's what we're trying to do: understand what makes people tick, understand how to explain the world. And I think what you're saying is, how do you get that all into some mega computer and
that's right,
use it in some.
Yeah, that's right. Yeah, even beyond the everyday, actually, what Deepak was saying, a lot of. Actually, I think I'm curious what you think, but everyday physics and science is okay, actually, and LLMs do capture. If I drop this glass, the LLM knows it's going to drop, and maybe a robot will know it's going to drop, and that's pretty easy to learn. But exactly to calculate, how this water will move if I shake the glass, well, that's much, much harder. And for many complicated or advanced applications, you actually need to know that, and then there's just no knowledge like this. There's no reliable knowledge like this in any of such models right now.
But Deepak, how are you teaching a robot how to think about that?
Well, I think I would say robotics also has its own hype cycle. Like many times you think, oh, robots are coming, but they don't. And the interesting part here is, if I tell you what we teach robots to do, you will say, it's very boring. Like, for instance, if you look at the internet, you can find so many videos of robots doing backflips, running, walking, like humanoids going in a variety of areas. And people get fascinated by them. And they say, OK, robots are coming. And the interesting part is, even if I ask people in the audience, like, you may have seen humanoids doing backflips, but really now think back, have you seen humanoids doing something as simple as climbing long set of stairs? And turns out there does not exist results out there.
Cleaning the kitchen.
Well, that's much more advanced. I'm saying even basic, as simple as climbing a stair. And this is where the interesting part is. There's Moravec's paradox. Hard is easy, easy is hard. Now, Hans Moravec was one of the founding figures in AI. And when AI was founded, after 30 years of working in robotics and AI, they wrote this quote. And what does this mean? It means that as human, you would not pay anybody hundreds of thousands of dollars to watch them climb stairs. But you would pay that much money to watch somebody throw a ball into a hoop from a faraway distance or do a backflip. Now, all of those things which look so attractive to us as humans, because we cannot do it, and very few of us can do it. But for a computer, it's exactly the opposite. Why? Because backflip is a free space motion, right? You can know about your own body completely. And when you know everything, that's what computers are good at. We have had flights, aeroplanes for 100 years because they are free space motion.
Free space motion.
And but in stairs, you have to still interact with every single stair you are climbing, because any single thing can cause the whole body to fail, and that's why it's hard. But when you see results out there, you don't even realize like this is hard. So we spend most of our time in doing things which humans think is easy, because that's what has led to intelligence in humans.
You as your company, that's what you're trying to
exactly.
do. Like there's a picture on the website of washing the dishes. How great would that be to not have to do that, right?
Correct. So that's the thing. That's the other part. Like, it would be actually great if you have robots in homes, but it would be very weird if you have robots in home in the next 6 months to 1 year, and you don't see robots around you everywhere else. Like, before robots come to your home to do your dishes, your laundry, you should start to see them in hospitals, hotels. Like, I call my hotel for a toothpaste. It takes like 2 hours. I have to go down and get it myself. Would be nice to have them. Like in enterprises, factories.
But why is that so much more important to have it in sort of like semi-public spaces before private?
Yeah, so this is a very good word, semi-public. So I use the word semi-structured.
Okay.
Because homes are completely unstructured. Factories traditionally have been fully structured where robots are. It is semi-structured. Like a grocery store, hospital, it is almost like home, but there is still some structure. And from that scenarios, you can, because robotics has no data, remember, the earlier problem. So by deploying in semi-structured scenarios, which are a bit easier than anybody's home, you get data to bootstrap the problem. You establish this data flywheel, and then this serves as the base model to get into homes.
And so what you're trying to do with your product is they have to be solving their own problems because there's not this data to constantly.
Yeah. So you can get data by deploying robots, right? But to deploy robots, they have to function. But to make them function, you need data. So you have to somehow start with easy but useful scenarios, deploy these systems, they get better, and as they get better, they get more data, then you go to next complex problem.
So your valuation has been skyrocketing. So I want to come to you in a second, but about why, like what investors are looking for. But first, just to stay on this, is that you have on your website, we need to deliver tangible real-world value. Like, why is that something that's so important? You put it right on the website, as opposed to some of the more theoretical scientific things that are still in the ether.
I would love to not have to deploy. Like I'm a professor at CMU, right? I love to not do that. But if there was data, again, it all comes back to the same first principles. Like in robotics, there is no data. I can build all these results in lab, but the data flywheel will only get established when robots get out there and deployed. Like, we don't think of deployment as, like in case of OpenAI, for instance, right? They did research and building for 7 years. And then ChatGPT happened, and first week, 1 million users. First month, 100 million users, right? That's the scale of deployment in the digital world. It can move fast. But physical world, like supply chain, like even convincing companies to really deploy this physical system in your world, even in your home. So I think of deployment in robotics as a technical challenge. It is not you cannot have this post hoc after you build this. So that's one reason. Second is this flywheel is the reason robotics will happen in the future.
So the real-world application isn't just to make investors happy; it's actually part of your science.
Exactly, part of the science. Like Tesla self-driving cars, like they have data, and hence they get better over time.
Okay, $14 billion valuation in 6 months. So Adrian, what makes a sort of new AI company most attractive right now? What are you looking for?
Well, exactly what Deepak said. It's all about real-world impact and how you can build a new business model that is a step change from whatever has been there before. So evaluation is always a kind of like a reflection on how different the business will be once the company is deploying, and how much more you can do with much less resources, because then that's more profitable. That is turning into actually profits at the unit economic level at the company that are scalable, that then make the company so valuable. And that only happens, of course, if AI is actually deployed. if AI is actually not only in the research and in the lab, but actually interacts with the real world effects. And I think for that, the biggest lever is not only what you can replace in terms of existing business processes and business models, but especially and even more so also the ones that are only possible because this technology now exists. That's what we usually call exponential innovation, right? It wouldn't be able to exist without the technology. But the funny thing about humans is they always, as it was also said before, they always obsess about technology and they're usually misjudging the impact of technology. The interesting thing here is once people stop talking about technology, it usually is here, right? So
It just becomes part of your life, and it's not.
who today talks about internet technologies? No one. We all talk about the applications on top, right? Right now we talk a lot about AI, but once AI is here, we're going to talk about the applications and the applications that then tend to be good business models. So that's what we are.
And one example of that is self-driving. I remember 5 years ago, everybody self-driving, where there was no car. But now if you go to SF or Palo Alto in California, you can find like more self-driven cars.
Yeah.
But nobody talks about it because it's boring now. And that's one of the examples of this.
Andrey, I want to come to you because you're living it, you're trying to recast your business, and it all seems like very exciting, but it's hard, right? I mean, what are the biggest challenges you're facing in terms of taking your base, turning it into a new product that was going to appeal to someone like Adrian?
Yeah, I think we in general enter in this kind of moment in the life cycle of software where pivots would be a more normal thing, because to build software, to ship software, now it's becoming super fast, super cheap. And kind of, for me, it was an interesting moment when we scaled our product to tens of millions of users. It became commodity to a degree, what you guys were describing, correct? It's like everyone started to use visual collaboration. We alone have more than 100 million users on our platform, and we're not the only platform. So it became a commodity. And then you have to step back and think, okay, now what should you do with that? And how you build the next horizon of the technology and the next category and the next problem that you can solve, that you are uniquely positioned to be solved. And when you start the company from scratch, you have any opportunity to go in any direction. But when you have your existing customer base, your existing user base, your brand perception, you need to think about where you have permissions to play, but most importantly, where you have permissions to win. And that should match with what people actually are ready to use and what they actually are ready to buy. Because you may have permission to win, but if the budget is not there, or it's number 5 priority for your target persona, then it also doesn't work. And then the bigger the business is, the harder to find that next horizon that will be 10x to your business. So for me, all of those things were quite interesting to explore over the last couple of years, because we were trying to kind of zoom out and understand how we can change ourselves, but change it in a way where it will solve even bigger problem than we were solving before, and solve it in a way where we will be uniquely solving it compared to other like big labs or hyperscalers. And that's how we were navigating that pivot over the last couple of years. And we'll see next year. We just shipped out this new product a couple months ago, and we see some good traction, but real results are, happening with some delay when you kind of get your customers on the journey with you.
It sounds interesting to explore, but also pretty scary and hard.
It's quite hard because you have like 1,600 people in your company. And everyone needs to understand where we go, why we go. But you start a company with 5 people, it's even hard with the 5 people to agree where you go, bring people on the journey. But when you have 1,600 people, and some people join more established company, correct?
Yeah, so let's talk about that. I'm going to go to questions in just a minute, but I want to talk about the competition for talent, because I'll say as a journalist, we're writing a lot about the talent wars from the biggest, best-known companies. So how do you all compete? You all have obviously good brand names, but what is the competition for talent like off the charts, hard to get people, hard to pay? Do you want to speak to that, Deepak?
This is one of the things which I did not estimate, like how hard, how much your mind space it takes as a founder.
You didn't anticipate?
I didn't anticipate that to this extent. But the thing is, in an area like ours, for instance, whatever we are building is actually very recent. The whole technology we are building is very recent. So there is not much incumbency you have to deal with. Which means that even if you miss some few top candidates, you get the next one and you can train them. Like this is very unique part about AI. Like if you take out maths or physics, you would have to read literature for 3-4 years before becoming useful. But that's not quite true in AI. Like if you have the right environment, right resources, you can get up to speed very quickly. And I think that's why you are seeing all these even young companies becoming very quickly into mammoth valuation and revenue is because it's an area where you can get in very fast with the right resources, get trained within the company very quickly. And being a professor helps.
Yeah, good pool of people. But then now why are Silicon Valley companies paying like $100 million pay packages?
I mean, of course, like talent is hard, and many of the candidates we've been trying to hire, they get calls on the same day that have to, from other big tech CEOs and so on. And so there's a lot of pressure, a lot of competition, and sometimes we win, and that's good. But actually, for example, one of the reasons why one thing I can say about Prometheus, we're in stealth, but one of the reasons why we have also offices in Zurich and London is to try to get European talent. That's a way to diversify, not just away just from Silicon Valley, but also in Europe. And there's tons of great talent here, and we'd love to grow here as well. So
okay, great.
Yeah.
So should we go to questions? We have one right here in the front. And please just say your name and your question.
My name is Hail. I'm a systems engineer and would love to hear your opinions on visual models, which DeepMind is mastering along with Google. Miro was one of my favorite tools, so I'm very interested to know if you have done any social engineering on the visual data sets that your users are doing to build your own models on that. And would you, at certain stage, sell that also to companies like Deepak and so on?
Sir? Technical?
I mean, I can give you my 2 cents on, you mean things like Nano Banana or, sure, yeah.
Genie and Via.
You mean like more like video models? Yeah, I mean, they're incredible. I used to train video models years ago, and and they were terrible. You couldn't get anything done. Actually, they would just not visualize anything. And today, those things are really, really good. Speaking of real world, they by looking a lot of video data, they do capture a certain projection of the real world onto these camera pixels, right? So we record the real world to these camera pixels, and they capture that. And if you train on all the data out there in the world, you're going to capture some of that information. That's pretty cool. There is a limit when you're talking about serious applications or serious use cases for these type of video models. There's a lot of the real world that actually pixels don't capture, that these cameras don't capture, and so this stuff is not in these models, and that is maybe a limitation. But I mean, I think they're amazing. Yeah. No, not in. I'm not a Google DeepMind.
Yeah, on our side, what we did over last year, we came up with this concept Canvas as a prompt. So today, like the majority of LLMs are prompted through voice or through text, correct? And Canvas capture all different modalities. It captures like sticky notes, it captures embeds, it captures all different things that people would post there. And we made Canvas as a prompt, so whatever you select on the Canvas can be understood by the LLMs and turned into the output that you want to turn. That's kind of the step number one. The step number two, what we will do is we will help companies to bring this team organizational intelligence with artificial intelligence together and like train corporate models eventually, those who want to do it. Because I spoke, for example, in Japan a few months ago with a few customers, and there is a lot of knowledge that sits in the heads of people of kind of the generation that might retire soon, and they're thinking how to kind of transition that knowledge to the younger generations. And if they collaborate, even in the simple workshops together and whatnot, you can train corporate knowledge, train this LLMs that are operating within the corporate environment and make it smarter and more contextual.
That's amazing. I want to get to a couple more questions because we have so little time. How about right here?
I'd be interested to hear, do you think that we might be on a wrong path with building these huge hyperscalers? Could it be that China is going on a better way, that we are going to get more smaller models, more specialized models, and that some of that infrastructure investment will be stranded assets soon?
Who wants to go for that?
I think one of the biggest misunderstanding is that when you build a data center, it's all used for training this one giant brain. That's not where the resources go. They go in the iterations. Like, I think there is something like in skydiving, there was this record in I forget which year, like 70s or 80s. Like, from an insane height, somebody jumped from the parachute, and people thought it was not possible. Like that person would not survive, and they survived. And people thought this record will never get broken. 4 weeks later, record gets broken. 8 weeks later, next person gets higher, higher, higher. Because once you show something is possible, you can always optimize for it. But the first time to show it's possible, that's where the resources go. Like even in case of, let's say, OpenAI, they're working on so many parallel threads. I'm sure DeepMind as well. And many of them you will never see, they will never see the day of light. And that's where the resources go. That's where these hyperscalers are used at massive scale. So the model size, it's in everyone's benefit to make it smaller, more efficient, because there is so much more to capture than what we have captured in models. So this is the one distinction. The hyperscaler are used for more iterations to do the breakthrough.
Okay, right here.
Hey, Mario from Globals. Adrian mentioned about business application AI. I'm wondering from the panel, in the next 12, 18 months, what do you think the deep tech breakthrough will differentiate the AI companies, the AI theater companies?
What was that, AI?
Applications.
But AI theater?
No. So which deep tech breakthrough we differentiate the AI companies with the AI wannabe companies or theater companies?
The real between the performance ones.
Okay.
Like what is going to be the key breakthrough that differentiates?
So you mean like the old joke, AI companies are done in PowerPoint and machine learning companies in Python?
Exactly.
Honestly, like...
It's an inside joke.
Sorry. So honestly, I think, again, it doesn't come, like in research, it always comes down to technology. On the application side, when it moves from research, from the lab into the real world, it really comes down to, and this was also what Deepak was saying about, the teams. Yes, it's incredibly important you have a kick-ass research team that creates all these breakthroughs. And then you need the application engineers that actually make it go into reality. And that's when it becomes a company before it's research. And so I think the distinction will, in the end, be made who is able to create the real-world impact and who is able to create a sustainable, defensible, and growing business model around that makes a company sustainable. That is going to be the distinction. Because even if today you look at all these sprawling AI companies that grow super quick, but sometimes have terrible unit economics and literally torch money in super speed, well, not all of them are going to make it, because in the end, business model means you can make money from something and not just revenue.
So it's not just science, it's the differentiator, but business acumen. Another question here, let's see. We'll stay in the front, I guess, okay? Going to the guy with the North Face hat.
Very diverse.
Way more biased towards the first.
My name is Georg Stieler. I have a question for Deepak. So as I understand you have a very generalistic approach and want to build a universal brain for robots. I spend a lot of time in China, and I see different approaches there. We have companies like X Square, Galaxy Dynamics, TAS, and they try to build now full-stack solutions for very clearly defined verticals that require intelligent solutions. And from that, they want to connect these different gains from different data flywheels. What do you think your long-term approach is most superior?
I think if you look at, I think this, since the panel began from LLMs, I'll draw an analogy to that directly, right? This is exactly how, so robotics is nothing new, by the way. Robotics has always been like this, verticalized, task-specific, and then you iterate on that over time. And you get more specialized towards the task. So there has been, if you ask how robotics works, this is how it works. But I would not say this approach has been successful. Otherwise, I mean, imagine which technological thing you saw a demo of in 1960s and where it is today. Almost everything that you see, I mean, except for nuclear fusion, which is always 30 years away, almost everything has made it in technology in a remarkable fashion. But robotics looks almost the same, right? So this approach is already there, so I will not talk about this. But I say, what alternative can we do? On the alternative side, in the language land, before these models, everything was specialized. Like as I said, translation, question answering, reasoning, coding, theorem, they were all separate systems. What LLMs provided was a base foundation where they all can be shared. Now, that does not mean there is one model to rule them all. Like you have one model that does everything at the end of the day. You now then fine tune it. So the idea is you first go general and then you go special. Because if you go specialized from beginning, you will not have enough data of that domain for you to capture all the corner cases. So generality only helps you deal with all the corner cases so that you can quickly adapt to new applications. And that's our approach. Like, and which is very painful though, which means we have to deploy in diverse areas. If you only do one area, we get the fear of like mode collapse.
Okay, I'm going to the North Face hat here. Go ahead.
Hi, Philip from QuantPy. Since the data for robots, like real-world data, seems to be the bottleneck, what do you think about synthetic data, simulations, and what do you think are the biggest challenges / opportunities there?
That is an excellent point. That's what we do. Like, we train with human videos. That's one, and second is simulation. But it's a different kind of simulation. It's not to put the real world in simulation. It's not like Matrix trilogy series like simulation, where you cannot distinguish reality from simulation. We really use physics. That combined with videos. Now, this is a good data, but it is not exactly the ground truth data for robotics, because ground truth data for robotics will be robot data. Like in language, you have English data on the internet. That's the same data which we speak, like speaking right now. But that's not true. So you have to really innovate in that area to bridge the gap between simulation and videos and real. So this is how we train this, the base model. But then we can collect few examples on the robot side and then fine-tune that. So robot data is low in scale, but it's high quality. So we should use it preciously, which is in the post-training time, and that's what we do.
Now, do you want to jump in on this, on synthetic data? Do you have a view?
I actually think so. As a scientist, I'm quite an empiricist. I do think that, as Deepak was saying, ground truth, real-world data is ultimately the ground truth. But there are many things we can't measure, and I think so. So you have to rely on our best simulators of all kind to actually put forward for certain areas, like whether it's physical simulation or it's movements and so on of things, and there are different levels. So I think that simulation will play an increasing role going forward in many applications, from robotics and also general intelligence.
Wonderful panel discussion. My name is Aziz. I'm from Kyrgyz Republic, Central Asia, 8 million population. And what you recommend, it's near future, 5 or 10 years. I fear about nations who can build LLMs or nations who cannot build LLMs. And gap is become bigger. But on the one hand, AI brings equality. For example, we have in Kyrgyz Republic strong AI engineering school and community. We built AI for own language, Kyrgyz language, and we spread it out. It is open source. We spread it out among the nations. What do you recommend for nations who cannot build LLM?
You can't build. What do you recommend? Who wants to?
Well, maybe it's for.
Well, I would say, again, see it as a commodity and then think about the application layer. Because today, there's a very small number out there that provides hyperscale infrastructure. Why? It's hard, but also it's commodity. So there's not going to be hundreds of companies providing these ingredients. But when you look at the advent of the internet and the cloud over the past 20 years, and when you analyze the business models and who is making how much money, and you think about all the internet businesses and the cloud running them, well, I guess we looked at that 2 years ago, and there's a value capture between 3 and 7% on the infrastructure, and all the rest is happening on top of the application. So that's what I would recommend, focus on the application, not so much the infrastructure. Somebody on the internet mentioned that when refrigeration came, it was not the refrigerator companies that made the most money, it was Pepsi and Coca-Cola.
Because they could use refrigeration in an interesting way, right? Okay, we have time for a few more questions right here.
Hi, my question is either to Nal or Deepak. So I had AI at an energy trading firm, and we deal with enterprise intelligence essentially, where there's a lot of sparse data. So how is the robotic brain idea or this physical world AI that you're talking about different from a sparse data LLM problem?
I would say it's not. It's the same problem. But the difference is you can at least fine-tune something. So you have something that is fine-tunable. And in robotics, that doesn't exist. Everything is sparse. I think, yeah.
Yeah, I think that's a good answer. Yeah.
Okay, go into the back. There's a fellow there in the back.
Hi, this is Dhawal. And the question I have for Deepak. How do you see the use case of robots that think in a highly regulated manufacturing environment?
Highly regulated?
Manufacturing environment, as an example. We have robots there, but the margin of error is very less. So how do you see that? Or correct. Is there a use case? Yeah,
so correct. I think so.
Just repeat the question because I didn't totally hear it.
So the question is, how do I see the role of robotics in highly regulated scenarios? And there are already robots there, right? So I want to distinguish this very common confusion. It's like automation and robotics. And they're often used interchangeably. For automation, you may still use robots, but I wouldn't call them the robotics that I am referring to here. Because in automation, the scenario is you may have a robotic arm doing stuff in a factory. Usually, those robotic arms will be in a cage, in a red tape area where humans cannot go, because everything is measured ahead of time. Even a screw or a bolt will be at the exact same location 100th time, no matter what, right? I would say this is already there in factories. It's scaling everywhere. Two things. It requires restructuring the whole, only rich companies can do it because it requires building from scratch for automation. You cannot go into existing spaces and automate things because you cannot measure everything where humans are around, right? This is more like microwave. When microwave is running, you cannot put your hand inside. It's doing its own thing. It will do a perfect thing, and that's where things are. What AI-driven robotics enables is because even these factories which have automation, they have folks working and people working, making that part more efficient. Even if you look at a manufacturing line, usually if you do studies, you'll figure out that the most time is spent in transferring items from here to there. And if somebody could give them all the right items, the people can become 30–40% more efficient. But doing that is non-trivial because it requires to act in the real world around people in a safe manner, which this kind of AI-driven robotics will change. So automation will still be there. It will still have its place. But this will enable things where people are today involved. Because whenever there are people, there is some chaos or some randomness, which AI can deal with.
Okay, any other questions? Well, I have one here, and then I have one more. Go ahead.
My name is Alexandra. I have a question for Andrey. With the development and growth of AI products, how does Miro manage to retain the customers, those who, let's say 5 years ago, Miro was a unique product. And now with the growth of AI alternatives, there are so many other options that they can use. So what do you do to retain the customers?
Yeah.
Any ideas for?
Yeah, I mean, good news, we have a great loyalty and customer base. We've invested a lot in the brand, and we are the leading company in our space. So that's kind of what creates the moat and loyalty. But then beyond that, obviously, when we built originally the business, it was product-led growth business. So people were discovering the product, they were jumping on the product, start to use it, and then it became kind of collaboration layer or productivity layer inside the company. Now, with our AI-first approach, we are transforming completely our go-to-market model, and we've introduced, for example, we call this team Kite. It's a customer AI transformation team, and that team goes super deep with the customers and trying to understand and work backwards from what the customer is trying to achieve, how we can accelerate 3 times, 5 times the innovation processes in the company, and we are building those AI workflows, implementing those AI workflows together with the customer, which is a way different approach than when you would kind of just give the product and people will figure out it's on their own. I think it's in general the trend that we see in the market where, especially with AI-first solutions, you can't just go and do PLG motion. You need to be deep in the customer business and the customer problems, because a lot of things have to be rethought from scratch, and you need to be a trusted advisor. You can't be just a software vendor.
In other words, you're not obsessing about building a product, but you're obsessing about creating value.
Yeah, exactly. Like deeply partnering with the customer and being on the journey together and developing the solution together rather than just kind of giving the software. Because again, software, like our type of software, any software got commoditized. You can write software now quite fast. That's it. Like,
I'm going to do a lightning rod here. I just want, if you were not doing what you're doing now, and you could work for one other company out there, it could be a tech company, an investment company, where and why? Just really quickly, because they're keeping us to the time. Who wants to go first? You must have some company you admire.
No, I'll go and work somewhere in the mountains in the hotel on a reception, and we'll have and we'll have fun snowboarding down over the weekend rather than go and write the 500 follow-ups after the conference over the weekend. So yeah, that's what I would do. I would just enjoy the nature. Yeah.
No?
Yeah.
Well, on the same vein, I think I would love to design boats. Actually, it's my design boats, and I think I would just I think we're fun to be a boat engineer.
Boat engineering in your future.
I would do physics work on fusion.
That I didn't hear.
I would work on physics and work on
physics.
Yeah, nuclear
keeps
fusion.
coming up today. I know you all know that. Okay.
Yeah.
Fusion.
Nuclear fusion.
Nuclear fusion.
Yes.
Fascinating. Okay.
Yeah, I was also going in the same direction. I would say either space or snow.
Both good. Thank you, everyone, for being here. Great panel. Thank you so much.
Thank you.